So now remember, he will not be replacing whatever card he selected. He will not be replacing it. Now remember, the diagram is not telling you what is going to happen. It is displaying all what is possible. So that's why the word if is important. If is a green card he selected. Here it is again. If is a green card he selected. You can even use the word if instead of after. If is a green, what is the probability of him getting another green? If it was a green. Okay. What is the probability of him getting a green if it was a green he selected? Can anybody would like to, guess the answer? Taking into consideration, if it was a green, he will not be replacing it back into the box. If it was a green. Will it still be 10 over 15? Considering the fact that if it was a green, he will not replace it. He will put it on the side and he will go back into the box container to try to select. So what is the probability of him getting another green? If it was a green he selected in the first selection. Anybody would like to guess what number comes there? And why? Yeah, there. What is the probability of him getting another green if it was a green he selected? No, you're not going to times it. You're going to use that formula. This is the formula you're going to type. The times in will come when you calculate in the outcomes. That's when the times in going to happen, but not inside of the tree. There is no times in inside of the tree. It's in the outcomes you're going to get the times in, the output. We're going to reuse that formula. Frequency over total frequency. Bearing in mind, if it was a green, he will not be replacing it into the container. I'm asking, will it still be 10 over 15? If it was a green, considering the fact that he will not be replacing that green card in the container, what fraction comes there? Is a fraction that comes in there? A numerator and a denominator. What is the numerator? What is the denominator? Anybody? Say that again. 10 over 15. You say 10 over 15. Now, bear in mind that he will not be replacing the green card. If it was a green, he will not be replacing it back into the box, All right. The condition is that he will not replace the selected card, but will randomly select another card. Bill is randomly selecting one card at a time from a box. Two cards, one after the other. In his first selection, he may choose a green or he may choose a brown. Whatever he chooses, he will not replace it back, but will go back and select again. Bear that in mind. So we are wondering now, if it was a green, we're not saying it's a green he chose, but if it was a green, what is the probability of him getting another green? What is the numerator? What is it 10 over 15 still? What it will be and why? Someone said no. What will it be and why? She said it will be 9 over 15 because he will not be replacing the green card he selected if it was a green. He puts it on the side. So you're saying in the container doesn't have 10 green cards anymore. How many cards it have in the container now? How many green cards that will be in the container? You say 9, right? And you keep in your denominator as 15? You said 9 over 15. Why 15? But think about it. Why 15? You correct, there will not be 10 green cards. There'll be 9 green cards because obviously, if it was a green, you would put it on the side. So when you go back in the box doesn't have 10 green cards anymore. 9 green cards. But but it doesn't have 15 cards either. Someone just said it doesn't have 15 cards either because and so what will be the denominator? 14, because 9 green cards. Remember, you take out a green card, you took out a green card. So it's 9 and 5, 14 cards in all, isn't that so? So think about it. Take out a green, you put it on the side. The conditions in the box will not be 10 and 5, it will be 9 and 5. 9 and 5 is 14. So the probability of him getting another green is 9 over 14. Okay? So if it was a green, the probability of him getting another green is 9 out of 14, because if it was a green, you see how I repeating if it was a green, right? Because it's probability, what may happen. If it was a green, then that green will not be replaced in the box. You will have 9 green cards and a total of 14. So the probability of him getting another green is 9 over 14. Please think about that. Now, but in his second selection, it may not be a green card he will select. Can anybody anticipate and guess what comes here? What is the notation that will be given here? What will be under this green rectangle? What notation that will be there? The probability of what? This is analyzing the probability of a green after green. But however, it may not be a green he will select. It could be a brown. So what do you think is written there? The probability of what? Exactly, the probability of a brown after green. Because either a green or a brown, a green after a green or a brown after green. And what is the probability of a brown after green? What if it's a green he selected? He will not put it back. And he goes back in the box. What is the probability of him getting a brown after he has selected a green? Can anybody tell me what is the numerator? 5 over 14, because there will still be 5 brown cards out of the 14. And 9 plus 5 is 14 over 14. Okay? So please apply that to your assignment. I know probably you may not be. Yes. How?